All right, so what's up? I'm going to be talking about, we talked about work and energy. Energy is a different way to look at kinematics. One kind of energy that we're going to talk about is kinetic energy. Kinetic energy is talking about the moving energy. Whenever I'm talking about something moving, it does have energy. Work is being done on it, or the work that has been done on it is now being released in the form of energy. Energy has the same units as work, so it's going to be measured in joules. The equation for kinetic energy, and if it's all right with you, this part, a lot of people have variations on how they represent kinetic energy. Some people use KE, some people use U, some people just use U, some people use T. Those are all representative of kinetic energies. And I think that for now, what I'll do is I'll start you off with KE. That's kind of the easiest thing to think about. It's kinetic energy, and it's equal to 1/2 mv squared. Now, I've always been a fan of deriving everything, so let's see where that comes from. And I'll be honest with you, I don't think I've done this before as far as like figuring out exactly where it comes from, so let me just kind of do it from scratch. I'm going to start off with my kinematics equations, but I'm going to start off with a special one. I think the one I want to do is the fourth one, which says V final squared equals V initial squared plus 2A delta x. Do you remember that one? That's the fourth kinematics equation that we covered back in, kindergarten. All right, the delta x is the same as d, so I'm going to replace that with that. Now, what I'm going to do is I think I'm going to take all the velocities over to one side. So I have V final squared equals V initial squared, minus V initial squared equals 2AD. And I'm going to kind of combine another piece of information. When we learned forces, we learned that F equals ma. All right, I'm just playing here. I don't really know exactly what I'm doing here. F equals ma. So I want to get A all by itself, I think. So let's go A equals F over M. Does that make sense? Sure. I can tell you the direction I'm going with this. Essentially, I know that the equation I want to start using is work is equal to force times distance. So somehow I want to get force into this equation over here. That's why I'm relating this A, because I'm going to substitute that A, get rid of the A, and relate it back to force. All right. V final squared minus V initial squared is equal to 2 force over m times d. Now what I'm going to do is I'm going to circle this part right here, and that's my work. So I'm just going to replace that with the letter W. Did I lose you so far, or are you good? All right. The next thing I'm thinking about doing is multiplying everything by m and dividing everything by 2. So I have 1/2 mv final squared minus 1/2 mv initial squared is equal to work. When I'm talking specifically about kinetic energy. All right, that's my equation, 1/2 mv squared. Or the amount of work that is done is equal to the difference in kinetic energies. So really, I kind of was able to derive this equation using two previous equations that we knew before, and it would be this one and this one. This is straight up from kinematics. This is force equals ma. So, what's really interesting, what's going to be really fun, is problems that we'll be able to solve using these kinds of equations. Problems that we'll be able to solve using work can also be solved using these kinds of equations, and sometimes, very often actually, it's easier to solve it using work than it is to use these two things. Well, why did I teach you to in reverse? Why did I teach you the easier one after the harder one? Because in order to get the easier one, we had to derive the harder one. We had to use the harder stuff to get to the easy stuff. So that's kind of why I didn't start you off with energy to begin with. Often you'll find that a lot of the kinematics problems that you can solve can actually be easily solved. If you're not looking for time, then it can easily be solved using energy, and it would actually give you the exact same answer much quicker. But in order to get to that advanced stage, we needed the harder baby steps to begin with.